Hello guys, welcome to the new video on Gradients Plus. In this video I am going to discuss about one of the most important topics of quants, that is number systems. So from number systems you can expect about 2 to 3 questions in every exams, and this topic is very important. So let's get started. So let's talk about the type of numbers. So broadly there are two types of numbers. So one are real numbers, imaginary number. So real numbers are of two types. First, decimals and integers. Now decimals again are of two types. One are finite and infinite. That means terminating and non-terminating. So let's take an example of half. Half is 0.5, which is a terminating decimal. But if we consider 1 upon 3, it is non-terminating decimal, which can also be represented as 0.3 dash. Talking about integers, so integers are of basically three types: negative integers, a 0, and a positive integers. So integers start from minus infinity, 0, and it goes on till plus infinity. So this 1, so if you start from 1 to plus infinity, these are called as natural numbers. And if you add 0 to the natural number, the whole thing becomes whole number. So if we talk about an infinite or a non-terminating decimal, there are two types again. One is a rational number, another is irrational number. Now rational numbers are those with the terminating decimal or a recurring decimal. That means if I talk about 1 upon 2, it is a terminating decimal, hence it is a rational number. If I talk about 1 upon 3, it is 0.33 till to infinity, but there is a fixed pattern that is repeating itself, that is 3 is repeating. Hence it can be represented as 0.3 dash, hence it is also a rational number. But if we talk about irrational number, let's take an example of pi. Pi is 22 upon 7, which is 3.1428, and it goes on to infinity. It is non-terminating and non-recurring. That means there is no pattern as such. Hence it becomes irrational number. So I hope the concept is clear. The numbers, rational numbers and the irrational numbers. So let's focus on the natural numbers. So natural numbers can be segregated into composite number, prime number, and the unity, that is the number 1, because 1 is neither prime nor composite. So let's talk about prime number, the most important numbers if we talk about the exam perspective. So prime numbers. So the prime number starts from 2, 3, 5, 7 and goes on. So the smallest prime number is 2, and it is also the only even prime number. So all the numbers except the prime numbers are called as composite numbers. Now coming to prime numbers, now all the prime numbers in the world that exist today have to be of the form of 6k plus or minus 1. Obviously the prime numbers starting from 5 have to satisfy this condition. So let's talk about 5. So how can 5 fit in this form? So it is 6k minus 1. Put k as 1, you will get 5. Talking about 7, it will be 6k plus 1. Put k as 1, you will get 7. That means all the prime numbers have to be of the form of 6k plus or minus 1. That means if I give you 4 numbers, let's say A, B, C and D, and if I ask you which amongst these 4 is not a prime number, that means any number which does not satisfy this condition will not be a prime number. But a reverse is not necessarily true always. That means if a number satisfies 6k plus or minus 1 form, that number does not necessarily have to be a prime number. Hence, this is not a selection criteria, this is an elimination criteria. That means all the prime numbers have to be of the form of 6k plus or minus 1, but the reverse is not true. Also, there was a question in CET that how many prime numbers are there between 1 to 100. So those who knew the answer, they got it easily, but those who did not know the answer, so they literally had to calculate the number of prime numbers. So just for your reference, there are 25 prime numbers between 1 to 100. Out of that, 13 are in 1 to 50 and 12 are between 50 to 100. So we have covered the basic types of numbers, and we have also seen the eligibility form for a prime number. So let's move ahead and solve few CAT questions which have appeared in the past year CAT question papers. Talking about the first question, the question says 2 of A, B, C, D are even and 2 are odd. Now in such questions, it is easy to just assume the values and solve rather than take the variables. So if I just assume the values of A, B, C and D, so let's assume this as 4, 3, 2, 1. You can assume anything, not an issue. So in this case, my A and C are even numbers and B and D are odd numbers. So let's try the first condition. The first condition says that A plus B plus C minus 2D. A plus B plus C minus 2D, that is 2. So that is 7. Now which of the following is definitely even? So 1, and I'm getting an odd number. That means A cannot be true. Let's talk about B. A plus 2B minus C. A plus 2B minus C. C is 2. So that is 8. Yeah, that means this criteria is fulfilling. So we'll see for the next. We'll park these criteria as of now. The option C states that A plus B minus C plus D. So A plus B is 7 minus C plus D is 3. I am also getting a even number. So this option also may be true. And the last option is 2A, that is 8 plus B plus C minus 1. So 8 plus 3, 11, 11 plus 12, 13, 13 minus 1 is 12. This is also an even number. So now what we will do, we will change the values. Now this time I will consider B and D as even number and A and C as odd number. I will start with option B, A plus 2B minus C. So plus 1, 9, 9 minus 1, 9 minus 3 is 6. I am getting an even number. So option C, A plus B minus C plus D, I am getting a 0. 2A plus B, that is 2A plus B plus C minus D. So I am getting an odd number. That means D also cannot be true. Now again I will change the values. Now this time I will consider A and D as even numbers. So A and D as even, B and C as odd. So let's take option B, A plus 2B minus C. So 4 plus 2, 6 minus 3 is 3, which is a odd number. Hence this is also wrong. So my correct option is option C. So this is how you can solve the question. So this question was asked in CAT 1997. Moving on to the next question. The question says that n plus 2 and n plus 4 are prime numbers. Find the possible number of solutions for n. Now as we have seen earlier, every prime number has to be of the form of 6k plus or minus 1. So let's assume that it is of the form of 6k plus 1. So if my n is 6k plus 1, n plus 2 would be 6k plus 3 and n plus 4 would be 6k plus 5. Now 6k plus 3, this number would be divisible by 3 because 6 is also divisible by 3 and 3 is also divisible by 3. Hence 6k plus 3 would be divisible by 3. Hence this cannot be a prime number, or it can be 3. There are only two possibilities. Now let's consider n as 6k minus 1. Now if my n is 6k minus 1, n plus 2 becomes 6k plus 1 and n plus 4 becomes 6k plus 3. Again, I have the 6k plus 3 which cannot be prime number or it can be 3. Hence, if these are prime numbers, 6k plus 3, one of them has to be the number 3 because 3 is the only prime number which satisfies the criteria. Hence, one has to be 3. Now, if I consider n as 3, this becomes 5, so this becomes 7. So 3, 5 and 7 becomes one of the possible solutions of n. If I consider n plus 2 as 3, my n becomes 1, which is not a prime number. Hence this is wrong. And if I consider n plus 4 as 3, my n plus 2 becomes 1 and n goes to negative, which is also not possible. Hence, there is only one solution possible, that is 3, 5, 7. Hence, answer to this question is option A, 1. Now, this question was asked in CAT 2003, but if you knew the concept, the fundamental concept of 6k plus 1 and minus 1, you would have easily solved this. So let's look at the last question from this concept. The question says, let x and y be positive integers such that x is a prime and y is a composite number. So let's assume x as 2 and y as 4. We can assume anything since 2 is a prime number and 4 is a composite number. So option A says that y minus x cannot be an even integer. So let's do y minus x, which is a 2. I am getting an even number, hence option A is wrong. B. So B says that x into y cannot be an even integer. So 2 into 4 is 8. I am again getting an even number, hence option B is wrong. Let's check for option C. X plus y, it is 2 plus 4, 6, divide by 2, I've got 3. Option C says that x plus y divided by x cannot be an even integer. I'm getting an odd one, but let's check for other values as well. So let's take x as 2 and y as 6. So in this case, x plus y divided by x, which is 6 plus 2 is 8, divided by 2, I am getting an even integer. Hence, this option is also wrong. The correct answer would be D, none of this. So this is how you could solve the CAT level questions by assuming the values. So I hope all the questions and the concepts were clear. In the next video, we will look at the divisibility concept. Also, if you haven't subscribed to our channel yet, do subscribe to our channel so that you won't miss out on any new videos. Thank you.